Now you can start. You can start.
Okay, complex angles. The main focus of this study here and this video to demonstrate how complex angles can be generated or how we can draw it. Although drawing the complex angle will not be part of this slide here, but definitely we will pave a path how we can do it. Before we start, I think we need to have an idea on complex numbers. This is fairly easy. Complex numbers usually comes from, let us say, a general form of x plus I, y, and I is the root square of -1. And then we are all familiar with basics of pure mathematics, that complex numbers can be represented on xy axis using Argand diagram. Definitely I'm not touching that part here, which is fairly easy, or can be represented in vector format. But now the main focus here is the angle. If, for example, here we have got an angle which is complex, the complex number or the complex angle, we can represent it like phi plus I sine. Obviously here there is no way in which we can represent that like by x and y coordinate. We do not assume that this is x coordinate, we do not assume that as y coordinate. Let's firstly touch some algebra or algebraic part of this. Trigonometric function and complex angles here. I think we are well familiar with the fact sine or cosine of any angle here cannot be below -1 or cannot be more than +1 here. And then theta is a real angle here. But in this section, if we have got the following example, let us assume that sine of an angle is equal to 2. Definitely at the start this looks very strange here, because how come sine of an angle is equal to 2? And this is the main purpose of this study. Sine of a real angle cannot be equal to 2, so what we do, normally we assume that complex format in which is phi plus I sine. Sine of this is equal to 2. Then we expand this by using sine of double of or sum of angles like A and B, sine of phi times cosine of I psi, and then so on, this is equal to 2. So we have got two unknowns here, but definitely those two unknowns we can now solve them simultaneously. So by using some identities, I think you are quite familiar with those facts. Cosine of I psi is equal to cos hyperbolic. Cos hyperbolic definitely is defined by this formula here. I assume that you are also familiar with this expression. The same thing here you have got for sine I psi, and then this is equal to I. Then I is the same as the minus square root. And then this is the definition of sine hyperbolic here. And then from the above equation, now you notice that the real part is going to be equal to 2, because the right hand side of the equation 6 has got only 2, and the left hand side here in terms of the I component is equal to 0. So it means I component is equal to 0 and the real component is equal to that. So if I take you back to here, once you expand it, then it means it looks like this, and then the real part will be equal to 2 and the imaginary part will be equal to that. Okay? So now you have got two equations with two unknowns. Those two angles, the imaginary part and the real part of your original angle theta. Now by solving those, for example, if you look at the first one here, cosine phi is equal to 0 here, you solve it. Certainly you get that general solution. You are quite familiar with the general solution of any trigonometric function. And then sine hyperbolic psi is equal to 0. Then from this solution you will get psi equals 0. And this cannot be a possible solution in this case, because if you assume psi equals 0, so it means the angle will be real, in which is conflicting with our assumption. Now the second part here, sine theta is equal to plus minus 1, but this plus minus 1 depending on the value of phi. For example, here sine of pi by 2 is equal to 1, but sine of 3 pi by 2, which is 270, is equal to minus 1. So it means you have got those solutions. Now, if you take the positive value, once you take the positive value, cosine hyperbolic of psi will become to 2, and then you substitute the definition of cosine hyperbolic, which is e to power psi plus e to power minus psi divided by 2, and now you solve this equation. Simply here, solving this equation is fairly easy. You multiply both sides by e to power psi, you will get a quadratic, and this quadratic you apply the formula, this will be the solution, and then you use basics of logarithms, then you convert it into logarithms. So you have got two solutions here. Now, it can easily be now shown that psi 1 is equal to minus psi 2. So one solution is equal to minus the other solution, which is fairly easy. This is equal to minus of that from definition of logarithm. And then here, therefore, the solution of equation number 4 will be this. So it means your theta, the theta in which we were looking for, this is the real part and this is the imaginary part. This means that there are infinite number of solutions, but all of them are complex numbers. So now we come to the next stage. If we now substitute the negative value, because don't forget we had either positive or negative value, so we will get a different solution, which is equal to minus 2, and then this one, if we solve it, this can be ignored because it does not give a valid solution. This is obvious from the basics of calculation. Now, complex angle triangles. Normally, what we are familiar with, a normal triangle like this one here, the angles are real, so we do not expect any angles to be complex. The sum of the angles must be equal to pi. If we are talking about a plane triangle, if a triangle is drawn in a plane, then definitely the sum is equal to pi. And certainly here, rule 2 is valid if the triangle is on a flat surface. It means this is rule 1. It's valid if the flat surface, but on curved surfaces, like this is on sphere, if you draw a triangle, definitely on sphere, you will get more than 180, and then the sum is now in here, in this type of surface, this is less than 180. These types of surfaces, it is less than 180, and there are some different types of geometry in which normally this is an Euclidean geometry, normally this is a spherical, and then this is called saddle geometry here. This is 180, this is more than 180, and this is less than 180. The reason for explaining that, it means now we have got some other possibilities in plane geometry here in which the angle is different. Now we know this fact here. This fact is, in any triangle in plane geometry, the sum of any two sides is greater than the third. Okay. The reason for discussing that is, we discuss few possibilities here and how or when the complex number comes in, or complex angle rather. So now if I have got a triangle in which similar to that, A equals to 2, B equals 5, C equals 7, then the triangle looks like this. Okay, 2 plus 5 here, and although it's not satisfying that definitely, because 2 plus 5 is not greater than 7, okay, at least because all of those must hold here, then the triangle looks like just a straight line. Straight line going here and then coming back, and there are two angles in which they are 0. There is one angle in which is 180, which still hasn't violated the rule. Now this angles, certainly as I just explained it here, one is 0, one is 0, and the other one is pi. Now cosine rule for triangle can be used to verify the above. Okay, like can this be possible on a curved sphere? I will leave that for yourself to study it. Now second possibility. The second possibility, if the sum of two sides is greater than the third side, although at the start this looks very unusual. So it means the sum of two sides is not. There is a mistake here if it is not greater than the third side here, then this looks strange here, but now we are studying this in a plane geometry here. For example, now take this example, like one side is 2, one side is 3, one side is 6. Definitely here, if I add 2 plus 3, is not going to be greater than that. Now what we do, we apply cosine rule, Once we apply cosine rule here, obviously here we get something in which is greater than 1. Perhaps we need to introduce complex angles here. So it means the angle A is not going to be a real angle, although in the next slide, not on this one here, we introduce a concept and idea how we can draw complex angles. Now, we solve in the same way as we had before, so I'm not going to introduce the solution here because the method is the same as we did before. And then finally, we get those solutions in which we have angle A is equal to 2n pi plus 0.521i, and similar procedure is applied to find out the angle B, in which is equal to that. Similar procedure is applied to find the angle C here, but the interesting point is, now if we add these angles here, this is that solution. Okay, this is the second solution of B, and this is the solution of C. If you add the angles here, despite the fact this is complex here, this is complex, this is complex, still we have not violated the rule in which the sum is equal to pi. In our next slide, we will talk about how geometrically we can draw those, or how geometrically we can draw a triangle in which two sides are not greater than the third one. Thank you.